Hello, I'm Pete Bellotta. Whenever a woodworking project throws you a curve, it's time to employ the services of a bandsaw or scroll saw. Bandsaws come in both stationary and benchtop models and are equipped with relatively wide blades for cutting curves in thick stock. Scroll saws, on the other hand, are smaller machines fitted with finer blades for making intricate cuts in thinner material. In this program, we'll look at both machines and show you why a woodworking shop just isn't complete without them. While bandsaws and scroll saws are both designed for cutting curves, the machines themselves operate quite differently. In a bandsaw, the blade is coiled around 2 or more wheels, with the drive wheel being mounted below the table. The wheels rotate in a clockwise direction, causing the blade to cut on a continuous downstroke. In large stationary models, the drive wheel is belt-driven by an induction motor. The same is true for most benchtop units. The upper wheel, which is the same diameter as the drive wheel, is spring-loaded to provide a means for both removing and tensioning the blade. Both wheels are fitted with thin layers of rubber, appropriately called tires. The tires keep the blade running quietly and tracking smoothly. The size of a bandsaw is advertised in a number of ways, with throat depth being the most common indicator. Throat depth, which is determined by the diameter of the wheels, is the distance between the blade and the midsection of the frame. Depending on the design of the saw, throat depth may be slightly less than wheel diameter. On this 18-inch saw, for example, the diameter of the wheels is 18 5/8 inches, while the throat depth is only 18 3/8. A scroll saw is essentially a motorized coping saw, and while all models move the blade up and down at high speed, the mechanisms used to achieve this reciprocating motion vary among manufacturers. The most common is the parallel arm design. Here, a pair of equal-length arms are mounted to pivots in the machine's frame. A rod and spring connect the arms at the rear, while the blade is held between the arms at the front. The assembly is driven by an induction motor, which is linked to the lower arm via an eccentric and bearing assembly. To keep the cut line clear of what little sawdust is generated by the scroll saw, a bellows is used to pump air through a tube that discharges close to the blade. On this machine, the bellows is mounted in the top cover and is activated by the movement of the upper arm. Like a bandsaw, the advertised size of a scroll saw is usually based on throat depth. Most 16-inch machines, like this one, are relatively inexpensive and make great starter saws. Bandsaws and scroll saws are equipped with large, clearly marked power switches. Benchtop saws of both types typically use a dual-colored paddle switch for the on-off function, while stationary bandsaws usually have large push-button switches labeled start and stop. On some saws, the start button can be disabled to prevent unauthorized use. The cutting speed of a bandsaw is measured in feet per minute. This value indicates the distance in feet any given point on the blade travels in 60 seconds. On a scroll saw, cutting speed is measured in strokes per minute, which indicates the speed of the blade's reciprocating movement. Some machines like this one have 2 cutting speeds. When fitted with the right blade, low speed should be used for cutting plastics and metals, while high speed is the best for cutting wood. The table on both bandsaws and scroll saws can be tilted 45 degrees by turning a knob or lever below the table. A built-in bevel scale indicates the degree of tilt. To allow accurate rip cutting, most bandsaws come with a rip fence that slides along the table's fractional scale. Usually, the rip fence can be mounted on either side of the blade. This is particularly helpful when ripping material on a bevel, since gravity helps keep the workpiece firmly against the fence. Most bandsaws also come with a miter gauge for making 90-degree crosscuts or for cutting angles. The gauge runs parallel to the blade in a groove machined into the table. Since the miter gauge is narrow, supporting the workpiece can be difficult, particularly when making angled cuts. A wooden extension mounted to the gauge solves the problem. On a bandsaw, the blade is shielded by the machine itself and a vertical blade guard that extends down from the top half of the housing. On a scroll saw, the lower part of the blade is isolated from the operator by a plastic or metal enclosure. To set blade tension on a bandsaw or scroll saw, a control knob or lever is used, which is typically mounted on top of the machine. Since a bandsaw uses a coiled blade, upper and lower blade guides are used to minimize flex when cutting curves. For efficient sawdust removal, all machines have dust collection ports that can be connected to a shop vac or central dust collection system. With their thin vertical blades, bandsaws and scroll saws are arguably much safer to use than their rotary cutting counterparts. Of course, that doesn't mean that accidents can't happen. In this section, we'll show you the safe operating techniques to ensure that they don't. To begin with, always wear a pair of clean safety glasses when operating either machine. Hearing protection is optional since these saws run much quieter than other woodworking equipment. Before using a bandsaw, set the blade guard so that the upper blade guide is within 1/4 inch of the workpiece. Also, be sure the material is free of staples, nails, or loose knots prior to cutting. When working freehand, guide the workpiece with both hands, keeping your thumbs a safe distance from the blade. When ripping a wide board, feed the material at a steady rate, using one hand to push and the other to keep the material against the fence. If your saw doesn't have a fence, clamp a straight edge to the table at the desired cutting width. When resawing, which is ripping a board on edge, it's not uncommon for the blade to veer slightly off course. This condition, known as drift, can be corrected by adding a resaw bar, which is a rounded guide, to the center of the fence. Attach the resaw bar to the fence and then set the fence the required distance from the blade. Now, rip the material freehand, changing direction as needed to counteract any drift. The secret to the resaw bar is the rounded edge, which allows you to pivot the workpiece left or right to maintain cutting accuracy. When ripping narrow boards or resawing, always use a push stick to move the end of the material through the blade. To prevent the blade from coming off the wheels, never back out of a deep cut with the saw running, and if a blade breaks, step back from the machine and allow it to come to a complete stop before taking further action. The techniques used for using a bandsaw safely can also be applied to using a scroll saw with some slight modifications, such as the rate of feed. Although the bandsaw and scroll saw both cut on the downstroke, the reciprocating action of a scroll saw means that the blade only cuts half of the time. Therefore, always feed the workpiece into the blade slowly to compensate for the blade's non-cutting upstrokes. Feeding material too quickly will increase the risk of blade breakage, which could lead to personal injury. Before starting the machine, place the blade guard on top of the workpiece and slide the material to within 1/4 inch of the blade. To reduce the risk of blade breakage, never start the machine with the workpiece against the blade. When cutting tight radius curves on a bandsaw or scroll saw, always make several relief cuts in the material first to reduce the stress on the blade. If you're a woodworker who likes to engage in the bandsaw versus table saw debate, well, you can chalk one up for the table saw when it comes to blades. That's because a bandsaw requires special blades for special cuts, whereas a table saw can cut just about anything when fitted with a high-quality combination blade. That means less downtime and more productivity. But enough controversy. In order to choose the right bandsaw blade for the job, there are 4 basic things to consider: teeth per inch, or TPI, profile, set, and width. When it comes to teeth per inch, less teeth, such as 6 TPI, will produce faster, rougher cuts, while more teeth, such as 12 TPI, will yield slower, smoother cuts. Generally speaking, it's best to choose a blade that will put at least 6 teeth into the material, but no more than 12. For example, a 10 TPI blade is a perfect choice for cutting a 5/4 board, which is really only 1 1/8 thick. Another factor that affects the quality of the cut is the tooth profile, of which there are 3 common types: regular, skip, and hook. With a regular profile, the teeth are set at a 0-degree rake angle. Rake angle refers to the position of the teeth relative to the blade body. A regular profile blade is good for cutting smooth curves in material 1 inch thick or less. A skip profile is basically the same as a regular profile with its 0-degree rake angle. The only difference is that every other tooth is missing. This arrangement provides wide gullets for efficient chip removal which is why the skip profile works well for cutting thick stock. However, the best choice for cutting thick boards, or for resawing as I'm doing here, is the hook tooth blade. With wide gullets and a